Since we're going to be working with substitution, I think it's just fitting that we do some sums that have to do with substituting. And we're going to do this through checking. So it says check the given solutions using substitution. How do we check algebraic equations again? Let's see if we remember in the chat. How do we check? How do we check algebraic solutions? Let's say you are doing an algebraic equation and you are at the end and you want to check that your solution is correct. How do we do that? We do the left-hand side and the right-hand side. In this case, we've just been already given the solution. That's right, Jason, left-hand side and right-hand side. So let's start with A. My left-hand side for A is x squared plus 5. And my right-hand side is 2x plus 5. Now we've been given that x is equal to 2 for this specific problem. Okay, so let's get checking. I'm going to substitute 2 on both sides. We're going to see if this is the correct solution. So I'm going to start off with my right-hand side, where I'm going to say 2 squared plus 5. And what's 2 squared plus 5? 2 squared plus 5. Or let me start with 2 squared. There we go. Nice, Alice. Thank you. This is 4 plus 5 is going to give us a 9. Okay, so that's our solution for the left-hand side. Now, if we go to the right-hand side, this one we have a 2 times 2 plus 5. And what is 2 times 2? It is 4. And if I add 5 to that, I get a solution of 9. So therefore, my left-hand side is equal to my right-hand side. And what does that mean about the solution x equals 2? It means the solution is correct. Okay. Wonderful, wonderful, guys. Now, we're not going to do all of them because I have a lot of work waiting for us where we are going. Let's do D. D seems very interesting. My left-hand side for D is 5 to the power of x plus 2 minus 3. And my right-hand side, it's all right, Maureen, welcome, is just 2. And for this specific case, we've been told that x is equal to 1. So we're going to substitute 1 and see if that is the correct solution. So I have 5 to the power of x, which is 1 plus 2, or minus 3. And this is 5 cubed minus 3. How much is 5 cubed? This is a 125 minus 3. And what is 125 minus 3? 122. Is that the same as my right-hand side? Is that the same? No. So my left-hand side is not equal to the right-hand side. And as per instruction, if you look here, it says if the solution is incorrect, provide the correct one. So we need to solve this equation, guys. So let's get going. 5 to the power of x plus 2 minus 3 equals 2. How do we solve this? Remember, we want x to be on its own. So what is my first step to get x on its own here? Nice, Alice. I'm going to move the 3, negative 3 over to the right-hand side. So then I have x to the power of 5 to the power of x plus 2 is equal to 2 plus 3. And what is 2 plus 3? It's 5, right? So I'm going to continue here. Let me insert a line so you guys can tell where I have not divided my sum. So then we have 5 to the power of x plus 2 is equal to 5. Okay, we have the same base on both sides, which means what? They can not cancel out, but we can bring my exponents down. Now, if there is no exponent on the right-hand side, then what number is there? It's a 1. So then x plus 2 is equal to 1. How do I solve for x? I take 2 over. Nice, Alice. You guys are on fire. And I have x is equal to 1 minus 2. And my final solution will be, therefore, x is equal to 1 minus 2, which is negative 1. Nice, guys. Let's check F. We can do F as the last one. F has given us a solution that says n is equal to 3. Let's check if that's correct. I have a left-hand side, which is a third times, that dot means times 6 to the power of n plus 1. And on my right-hand side, I have 13. Okay, so can we do anything on the right-hand side? Is there much we're going to do on the right-hand side? It's just a 13. So no, right? It's just going to remain 13. So on my left, I have 1 over 3 times 6 to the power of 3 plus 1. Where do we start with the sum? According to BEDMAS, where are we going to start here? Nice, 6 to the power of 3. And that's going to give me, you guys are great. Nice, Marlene. We started with exponents. What is 6 to the power of 3? 216. So it's going to be a third times 216 plus 1. Okay, we've done exponents. What's after exponents? After exponents, we do, what does that dot mean? It means multiplication, right? This dot. So do we add before we multiply? Is that possible for us to add before we multiply? No, so we have to multiply, right? And we go back to my favorite or my least favorite method. Is there a common factor between, oh, that was terrible. Is there a common factor between 3 and 216? I'm really trying to do this bracket thing. What's my common factor between 3 and 216? I'm going to stop doing that. It is 3. How many times did it go into itself? How many times does it go into itself? Itself once, and into 216, 72 times. So then I'm left with 1 times 72, which is just 72 plus 1. So my final answer for the left-hand side is 73. Is that equal to my right-hand side? No. Is not equal to the right-hand side. Now, what did they say we have to do if those two sides are not equal? We have to find the correct solution. Okay, so let us insert a line and find the correct solution for F. Because we know that the one they gave us is not the correct one. My line is terrible, guys. There we go. So let's get solving. A third times 6 to the power of n plus 1 equals 13. I want n to be on its own, and currently n is over there. So what is the first thing we have to do to try and get n on its own? Nice. We take 1 over and it becomes negative. So then I have a third times 6 to the power of n is equal to 13 minus 1, and that's going to give us 12. Great. I've gotten rid of my negative, my 1. So what else can I get rid of? What else can I get rid of? The third. And how am I going to get rid of that third, guys? How do I get rid of 1 over 3? I times. Nice, Jason. Times by what? Times by 3. Nice, guys. And then these two 3s are going to... What's going to happen with these 3s? They're gone. They cancel each other out. So then I'm left with 6 to the power of n is equal to 12 times 3, which is 36. Great. Okay. Now what do we do, guys? I have a variable which is an exponent. So that means I want the same bases on both sides. We're not there yet. We want the same base on both sides. Which base are we going to use in this case? 6, because I can change 36 to be what? Nice, 6 squared. And if you have same base on both sides, a 6 and a 6, then we can equate the exponents. So therefore, n is equal to 2. Nice, guys. How was that checking? Give me a thumbs up, thumbs down. Are we good with checking our solutions? I only have very few thumbs ups. There we go. All right. I'm trying to zoom out for people who want to take screenshots. There we go. And then if there are no questions, we're going to get moving. All right. Now, I'm going to go on to the next part, which explains to us one of the parts in which we use substitution, guys. Does this look familiar? What does this look like to you guys? What does this look like? Where do we use this? Nice, it looks like graphs. And that is a very, very, very big clue about where we're going next, what the next section is going to be. Okay, so how do we do this one again, guys? Let's remind each other. I have a bunch of values here. Where will I substitute these values? I have a -2, a -1, 0, 1, 2, 10. Where in my equation will I substitute it? In my x or in my y? Nice, in the x. So let's get substituting. Okay, I'm going to start with the first one. Y is equal to 3 times x, which is -2 squared, plus 4 times -2 minus 10. Okay, let's see. What is -2 all squared? As in the negative is inside the bracket. That is 4. Okay, so this is 3 times 4. -2 minus 10. So let's get going. What's 3 times 4? 12. And 4 times -2. Thank you, Spamandla. 4 times -2 is -8 minus 10. So then what's 12 minus 8 minus 10? 12 minus 8 minus 10. That is -6. Let's check. 12 minus 8 is 4, and minus 10 is -6. That is true. Okay, now that we have discussed how we do it, we're going to move fast. So y is equal to 3 times -1 all squared plus 4 times -1 minus 10. Okay, and this is going to give me 3 times -1 squared is 1. So then 3 times 1 is just 3. And then 4 times -1. 4 times -1 is -4 minus 10. What is 3 minus 4 minus 10? 3 minus 4 minus 10, that's -11. Nice. We're on to the next one. Y is equal to 3 times 0 squared minus 4 times 0 minus 10. These ones that contain zeros, if you multiply anything by 0, then your answer is going to be what? 0. So I have a 0 minus 0 minus 10. So then my y is -10. Wonderful. Okay, next one. 3 times 1 squared minus 4 times 1 minus 10. What's 3 times 1 squared? That is 3 times, no, that is just 3, excuse me. Minus 4 times 1, which is just 4, minus 10. And this is equal to 3 minus 4 minus 10. Yes, Londeka. Hello.
Hello, ma'am. Yes, ma'am. Ma'am, I wanted to ask, by the third block, in the sum you wrote y equals 3 into 0 squared minus 4. But in the
Times
sum it says
0.
plus 4.
Oh, it's plus 4. So I've been minusing 4 instead of plusing. Let's see. How
Yes,
long
ma'am.
have I been doing that? Let's check. Okay, so it was this one, the one before, and the one we're currently on. So it's
Yes,
actually
ma'am.
3 plus 4 minus 10. Nice. Thank you, Londeka.
Yes,
3
ma'am.
plus 4 minus 10. Nice. Very observant. Which is 3 plus 4, that is 7. And if you minus 10 is negative 3. Oh. You need to trust yourself more. So did you see the answer and then you were like, no, I'm just going to keep quiet. Oh, you must have confidence, Alice. And then the next one, we have y is equal to 3 times 2 squared plus 4 times 2 minus 10. Okay, let's get going. That's not good, Spamandla. That's why we don't finish exams, because you go back multiple times trying to check. It's terrible if you write the correct answer and scratch it out. I've seen it so many times, guys, and I can't even mark it right. So this is 3 times 4 plus 4 times 2 minus. It is heartbreaking, Alice. Can you imagine me having to mark it wrong when I can see you wrote the right thing? That is very, very sad. So what's 3 times 4, guys, for the sum? 12 plus 4 times 8. I mean 4 times 2, but I told you guys the answer. So what is 12 plus 8 minus 10? That is positive 10, because that's 20 minus 10 is positive 10. 10. And the last one, y is equal to 3 times 10 squared plus 4 times 10 minus 10. Okay, how much is 10 squared? 100 plus 4 times 10 minus 10. So then 3 times 100 is 300 plus 4 times 10. So it's 300 plus 40 minus 10. Therefore, y is 330. Now, how do we write coordinates again? They've given us a clue in the chat. I mean, in the table. So what is nice, Jason? We just need to remember my semicolon. I see you guys are using a colon. We don't use 2 dots. We use a dot and a comma. So for the first one is -2, semicolon, -6, close brackets. It's okay, Jason. That's why we're doing it here. So we don't make those mistakes when it's devastating. Second one is -1 with -11. And then we have not negative. I've crammed negative now. I've been saying negative for the past, I don't know how long. Is 0 with -10. What is my fourth one in the chat? Let's see us all do it properly with both my brackets and a semicolon. There we go, guys. The next one is 1 semicolon -3. And then we have 2 and 10 and 10 with 330. This is going to be very useful. Keep it in mind for our next section. Okay. All right, guys. Now, okay. Now we're going to substitute variables, right? We're going to substitute variables. Now, I know you guys can do this, so don't start freaking out now. But let's get going. So x is, at least they told us, x minus 2, x and x plus 2 are 3 natural numbers. What does it mean when they say are 3 natural numbers? There's a reason they told us that. What do they mean, guys? Let's start with the definition for natural numbers. Natural numbers. Not necessarily, Alice, those are consecutive numbers. Consecutive means one after the other, right? But why do they need to tell you that they are natural? Thank you, Spama. They're counting numbers starting from 1. So can any of these numbers be negative? Do you see why they told us that? That means all 3 numbers are going to be positive. So these are going to be positive. So we've gotten that out the way. They're going to be positive and they will not be fractions. Remember, natural numbers does not include fractions and decimals. Okay, so if at the end we end up with 2 solutions, we will automatically pick the positive solution because we know that they have to be natural numbers. If the product of the 3 numbers is 4 times their sum, determine the 3 numbers. What does product mean? Product is a multiplication. So we are multiplying it and is 4 times their sum. What does sum mean? It means we're adding. Okay. So let's see. First, I'm going to write their product. So their product is x times x minus 2 times x plus 2. Right? And then their sum is x plus x minus 2 plus x plus 2. So they're saying the product of the 3 numbers is 4 times their sum. So that means this product is equal to 4 times the sum. Do we all understand what I am doing here? X plus 2. So the product, the multiplication is equal to 4 times the addition of these 3 numbers. Then they say determine what the numbers are. Let's see what we can do here. Hopefully my brain is working. Earlier it was a little bit on a stump, but let's see. So how do we multiply these 3 on the side? How do we multiply these? Can I multiply all 3 of them all at once in one go? What do you guys think? No. So what do I have to do? What do I have to do? Multiply them one at a time. So I'm going to start with the x that is outside and distribute it. So what is x times x, guys? X squared. Ooh. This is x squared. And x times negative 2 times negative 2x. And this is all still multiplied by x plus 2. Okay, equals 4 times. Let's add my like terms in here to make things easier. Okay, I have x plus x plus x. And what is that going to give me? 3x. And I have a negative 2 plus 2. They're gone. So it's just 4 times 3x. All right. And now I have two binomials. How do I multiply two binomials? We first have to do the brackets, then times the x. That's fine, Jason. Remember, the order in which you multiply doesn't matter, because if I say 2 times 3 times 5, I can either do this part first, so I say 6 times 5, which is 30, or I can multiply this part first, so say 2 times 15, which is still 30. Okay, so because they're all multiplication, it will not matter which ones you multiply first. You're welcome. So let's FOIL these. First, x squared times x. How much is x squared times x? That's x cubed. Outer, x squared times positive 2. That's plus 2x squared. Inner is negative 2x times x. Negative 2x times x. That's minus 2x squared. It's squared because it's x times x. And then last is negative 2x times 2. Negative 2x times 2 is negative 4x. And this all equals a 4 times 3x, which is just 12x. Whew. Okay, now what? We're getting somewhere. We're getting somewhere. Now what, guys? Plus 4, but then the x's will be scattered. So what happens in this case? If we have x's all around, then we bring them all to one side. So which is the one that I'm going to move, guys? Before we factorize, Alice, nice. We have to move my 12x to join the other guys on that side. So then I have x cubed. What's 2x minus 2x squared minus 2x squared? These like terms. They're gone. So it's x cubed minus 4x. And if my 12x goes over, it becomes negative 12x equals what's left on the right-hand side. I've moved everything that was there, so equals 0. Nice, Alice and Spamandla and Jason. So then I have x cubed negative 4x minus 12x. Negative 4x minus 12x minus 16x equals 0. Now we go to that thing that Alice said we must do, which is factorization. How am I going to factorize this, guys? Is it a difference of 2 squares? No. Oh, Alice, we spoke about dividing by x. We don't divide by x, but what do we do with x? X is our... Think of the methods of factorization. Common factor. So we factor it out. So I'm going to write x over here. What is left for my first term? I know, Alice. I hope in the test you'll remember my voice. Thanks, Maureen. I'm left with x squared in my first term minus 16 in my second term equals 0. Can I still factorize what is inside this bracket right now? X squared minus 16, how can I factorize it? Ashley said yes. Ashley, excuse me. It's not binomial. There's a specific word we use for it. Well, specific term, not word. Think of methods of factorization. Nice. Difference of 2 squares. Dum, dum, dum. Ompa has entered the chat as well. And so has, yeah, Jason has been speaking, so it's fine. And Spamanda. Nice. So then this x I leave here. What are my two brackets for my difference of 2 squares? First factor in both brackets. First factor, not sign. We have x and x. What are my signs in the two brackets? A negative and a positive. And thank you. My second factor is a 4. Woo! We're solving for x though, guys. We're solving for x. Okay. Let's see. All right. Now, what happens once we get to this point? We have 3 factors. I have an x minus 4, and I have an x plus 4, and this is all equal to 0. What do we do? How do I solve for x, guys? Equate all of them to 0. Thank you. So first solution is x equals 0, or what? X minus 4 equals 0, or x plus 4 equals 0. Do you guys remember my trick from last week? How did I know that I was going to have 3 solutions? Let's see if we remember this trick. How did I know for a fact that I was going to have 3 solutions? Nice, Alice. I had an x cubed. This was telling me that I was going to have 3 solutions. So my first one is done, x equals 0. Let's work on the second one, or x is equal to, if x minus 4 is 0, then x is 4, or the third solution, x is equal to negative 4. Now I'm going to go back to that special part of my sentence. Are 3 natural numbers. Remember, we're finding the numbers, right? Spamander says the answer is 4. We know x is not equal to negative 4 because it is not a natural number, right? But why is x also not equal to 0? It's not a natural number. It's a whole number, guys. It's a whole number. Okay. So you must say, but x, nope, but 0 and negative 4 are not natural. Do you guys see the relevance of that part of the instructions? Therefore, x is 4. But that's not what they said. That's not what they asked for. They said determine all 3 of the numbers. We know the first one is 4, right? The first one was x. So the first one is 4. But the second one was x minus 2. So what is x minus 2? Which is 4 minus 2, and this is 2. And the third one was x plus 2, which is 4 plus 2, 6. So my 3 numbers are 2, 4, and 6. Woo, that was a beautiful sum. What do you guys think? I know, Jason, that was such a beautiful sum. I do want to say something else though, guys. I do want to say something else. I know in this case, they said they're not natural numbers, Annie. But if, I mean, they are natural numbers. But if they had said that these 3 numbers are whole numbers, you guys would have had to check 0. Do you guys see what I mean? Let's say they told us that these 3 numbers are whole numbers. Yes, inspections, Pamandla. The first one would have been fine, x equals 0. But what would have happened if you did this, x minus 2? What would you have gotten if you said x minus 2? That is negative 2. Would that have still been a whole number? Ah. So do you see why I say check or inspection? In this case, we could check from the first step by just looking at them. But if they had said these are whole numbers, 0 is a whole number. But what happens if you say x minus 2, you would have gotten negative 2. That automatically disqualifies this one. So always check, check, check. Do you see why substitution is important, guys? Very important. Alice says they made us work for their marks. Ah, but Alice, you must work, Pela. You must. I always tell my learners, don't be afraid to struggle with mathematics. Do not be afraid. That's what we want. Okay, we don't want you to struggle, but you guys get the point. For screenshotters, here we go. Are you guys ready for a brain break? We're going on a cruise again. How was the test, Maureen? We're ready for a brain break. And we are going on a cruise again. Oh. Okay. You guys wrote, oh geez, you guys are right. I hope it's going well, guys. I hope it's going well. How did it go, Rolivo? If you don't want to tell everyone, you can DM me. Please. Okay. Are we ready for the cruise? I'm going on a cruise and I am taking One Direction. All of them, I'm taking them with me. Okay, let's hear what you guys are going to say. I'm going on a cruise and I'm taking One Direction. Oh, Jason is going. Jason is going. Jason says he's taking the Beatles and you are coming with me on the cruise, Jason. Let's go. Marlene, were you here last week when we did this? Jason is taking all of the stuff. Pink Floyd, you are going, Jason. You are going. Let's see. Someone says, I'm going on the cruise and I'm taking the Bee Gees. Whoever's taking Queen, you are staying. You are staying. Queen. Nope. The Bee Gees is a very old one, so they... But yeah, whoever's taking the Bee Gees, you're going. Bee Gees is going. Does anybody see the trend? Whoever's taking Destiny's Child is going. Let's see. Whoever's taking Fifth Harmony. Now I don't know if Fifth Harmony qualifies for what I'm saying. Does anybody see what the category is? Does anybody say, oh, you think you know? Let's hear. Let's hear. Whoever said, I think I know. It's not just bands. It is not just bands. What is it? Alice says boy groups, but I said Destiny's Child was going, so it's not necessarily boy groups. And whoever said Pink, no, Fifth Harmony is also going. So it's not just music groups. Yes. Unmute yourself, please, and tell me how you get to go.
Ma'am, I don't know if I'm right, but is it like groups that are broken up or old groups? Oh,
Yay! Boo, 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 boo. Maya has it, guys. Music groups that have broken up.
mhm.
Nice, Maya.
Thank you.
Wow. Okay, now I have to, let's do another one, guys. Let's do another. Alice is like, that's why I'm taking them on a quiz, not a quiz, taking them on a cruise, guys. I'm so done, guys. I'm so done. I know, guys. Imagine we'd have a free concert. Wow. Okay, let's do one more. Ash, now I have to think. I have one in mind. I'm going on a cruise and I am taking a nail. You know those ones that you use to nail stuff onto your wall? I'm taking a nail, guys. Screwdriver, hammer, you guys are staying. Staying. I'm taking a nail and I'm going. Drill, staying. Snail, staying. Wood, going. Whoever said would, you're coming with me. Draw, staying. Glass, going. Yes, Pamandla.
Ma'am, is it like, I don't know if it's correct, but is it like based on materials or like structures?
Not really.
Ah,
Not really. Let's see. Let's see. Frame is staying. Iron is going with me. You are going, Ashley. Window is staying. Steel, copper, metal staying. Bricks staying. Yo, yo, yo. Nice, Jason. It's 4 little words. I thought you guys were going to get this one way before. It's just 4 little words, guys. I know after a difficult one, you guys think too much. That was a good one. That was a good one. So I first give you a hard one, and then I go very simple, and everyone just misses it. It is 4 little words, guys. Okay, lovely brain break. Let's get moving. Okay, now we're gonna have a little sneak peek for everyone who wants to take physics as a subject next year. Okay, this is the stuff you're gonna deal with. So let us have a little bit of a sneak peek and unpack our brains. How's that, guys? How is that? So this is still substitution in mathematics, but it gives you a little bit of a sneak peek into physics. So let's see, guys. A flea jumps from the ground and reaches a maximum height and then falls back down to the ground. The equation of this movement is given by d equals 20t minus t squared. All right, now in this equation, t represents the time. Geez, my hand just went south. T represents the time in seconds, and d is the distance of this flea above the ground in centimeters. Okay, so first question says, how far above the ground is the flea after 2 seconds? Where are we going to substitute that 2? It's not that bad, actually, I promise. Nice, Pamela, add t because it is time, and luckily we don't have to do any conversions because it has given us in seconds. So let's substitute. So my d is equal to 20 times 2 minus 2 all squared. Great. What's 20 times 2, guys? 20 times 2 is 40 minus 2 squared, which is 4. So then the distance above the ground is 36 what? Read your information. Centimeters. There we go. Okay, see guys, it's not that bad. Of course, I'm gonna have more questions, but it's not that bad. Okay. After how many seconds will the flea be 36 centimeters above the ground? And explain why there are 2 solutions for t. So now we are thinking, guys. This is where physics comes in and logic. Okay. So remember, d was equal to 20t minus t squared. D is 20t minus t squared. Now they're telling us that this is the distance. So where do I substitute it in my sum? Into d. Yes. So 36 is equal to 20t minus t squared. Great. How are we going to solve this, guys? How are we going to solve this one? Let me hear your suggestions. Don't be nervous. It's something we've done already in today's lesson. Equate to 0, which means I'm going to have to move my 20t and my t squared. Why am I not moving the 36? Why am I not moving the 36 over to the right-hand side? What problem is that going to give us? Nice, Maureen. Which sign, though? Which sign am I trying to fix here? Not t, but you're close. I want a positive t squared, because have we ever factorized the negative t squared, guys? Have we ever done that? No. So we want a positive t squared. This is why I moved the t squared that side. Okay. See? Application, thinking. So it's positive t squared, negative 20t plus 36 equals 0. Wonderful. I have a trinomial, which means I'm going to end up with what? A trinomial, which means I'm going to end up with 2 brackets. Nice, Ashley. Let's go, equals 0. What is my first term for both brackets? Nice, Pamela, T and T. My first symbol, according to this, is a negative. And does that mean keep or change the second one? Change, so my second symbol is... Oh, we forgot how to do this, guys. We are changing the second one, not the first one. We're changing this one. So if I'm changing that one, then my second symbol is a negative. Oh, we're forgetting. We're forgetting. Okay, let's look for factors of 36 that will add up to 20. I'm going to start with the first one. 1 times 36. What other factors does 36 have? It's 2 times what? 2 times, oh, there's also a 6 times 6 somewhere there. 2 times 18. There's also a 3 times 12. Are those all of them? Nope. There's a 4 times 9. I think that's all of them. Yes, that is all of them. Okay, now which of these factors? Both of them are negative, so they need to add up to 20. Nice, Ashley. So it's negative 18 and negative 2. Great. I have my 2 factors. They're both equal to 0. So how do I find my solution? Equates to 0. So t minus 18 equals 0, or t minus 2 equals 0. So my first solution, therefore, t is equal to... not negative 18, this goes over, so it becomes positive 18, or t is equal to positive 2. Now, why are there 2 values for t? Think of the scenario. Why are there 2 values? Not necessarily for this. That's how you identify that they're going to be 2 values. The question is, why are these 2 values valid? Remember when we were doing the sum that said they can't be natural, they have to be natural numbers or blah, 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 blah. Because what this says is what, guys? At 18 seconds and at 2 seconds, the flea is 36 centimeters above ground. Does that make sense? Does that make sense? No. Think of what's going on. What happens when you throw something up, guys? If you throw a ball up, what happens with it? It comes down. We're getting somewhere. So let's say this is 36 centimeters. You've thrown the ball up. It is at 36 centimeters. What happens after it comes down? At some point, it's also going to be at 36 centimeters. Do you see where there are 2 valid solutions, guys? That means on its way up here at 2 seconds, it was at 36 centimeters. And then on its way down at 18 seconds, it was still at 36 centimeters above the ground. The only problem is it was going in the opposite direction. Do you see, guys? Does this make sense? Physics. Physics. Wonderful, guys. I hope you guys are enjoying this sum as much as I am. Let's do the last one. After how many seconds will the flea be back on the ground? How do we know how to do that? Using this formula. D is equal to 20t. Is it minus t squared? Yes. If the flea is back on the ground, then what is the distance between the ground and the flea? Your ball left, it came back to the ground. No? So let's say it was here. It left, it came back. It's here. So then what's the distance between the ground and the flea? Nice, Maureen. It's 0. It's on the ground. Do you guys see that? It is 0 because it is back on the ground. So then, what am I going to substitute and where? Where will I substitute that 0 centimeters, guys? At D. Oh, I love this. So then 0 equals to 20t minus t squared. Let's get solving. 0 equals, this is not a trinomial, so what can we do? We have a t on both of them. So t is it's not difference of 2 squares. 20 is definitely not a square. Common factor. So what is the common factor? Okay, I just told you it's t. So let's take out t. What's left on my first term here? 20 minus what's left on my second term here? T. Now I have my two factors. So what do I do when I have two factors? What do I do when I have two factors? Make them equal to 0. So then t is equal to 0, or 20 minus t is equal to 0. This one already has a solution, but my second solution is, if I take this t over, t will be equal to what? 20. Now, we have two solutions again, but the question was, after how many seconds will the flea be back on the ground? Which one is the correct solution? How do you know it's 20 seconds and not 0 seconds? At 0 seconds, has it even left the ground, guys? No. So the first t equals 0, it's before it leaves. And the second one is after it has left and come back. Whoo.